whenever you find the intersection of something. So basically it's talking about simultaneous equations. In this graph, they give you two straight lines. So maybe one line is like this, another line is like this. In order to find out the intercept point, we are talking about when they meet each other. This point is called intersection. And then when we are asked to find the coordinates of the intersection, then what we have to do is we consider the first line. They say that first line the equation is 3y equal to negative 2x minus 3, which means that all the points on this line will fulfill this requirement. Let's say if x is equal to 2, then 3y is equal to negative 4 minus 3, and y is equal to negative 7 over 3. So when x is equal to negative 2, then y will equal to negative 7 over 3. This point will fulfill the requirement here. Not only this, but every point on this line, the x and y at that point will fulfill this requirement. And we also have another line, L2. So L2 is 2y equal to 3x minus 2. Again, that means every point on this line will fulfill this requirement. Whenever we look at this point what is so special is it's lie on L1 at the same time it's lie on L2. So at this point, we know that it's fulfilled the requirement for the first line. It's also at the same time fulfill the requirement for the second line. That's why we are basically solving the simultaneous equation of the two straight lines. In the following, you just use your own method to solve the simultaneous equation. But no matter what you have to do, you should tidy up your equation. How many x, how many y equal to constant. And then either you use calculator or you calculate by yourself is totally fine. If you solve it by yourself, I want to make 3 and 2 be the same. So the best method is the first equation, both sides times 2. And the second equation, both sides times 3. Then I predicted that the y term will be the same afterward. First equation, 4x plus 6y equal to negative 6. Second equation, negative 9x positive 6y equal to negative 6. We find that we successfully think that 6y is equal to 6y. So we can remove this term by subtraction. I try to use left hand side minus left hand side should equal to right hand side minus right hand side. So 4x minus negative 9x should equal to right hand side. First right hand side minus the second right hand side. 13x equal to 0. So x is equal to 0. To get the y coordinates, you can use either one equation because it's lie on both lines. So which equation you use, you should get a consistent result. Let's say if I use the first one. So the conclusion is at this point x is equal to 0, at the same time y equal to negative 1. So 0, negative 1 is the point of intersection. I just roughly draw this graph before, so it's not accurate. They should intercept at y-axis here. So question 10 is similar, so we just solve the simultaneous equation for the intercept point. And then we try to solve it, maybe both up the first equation, both sides times 4, so that I can have 4x. We have 4x and 4x. Of course, I would like to subtract them. So 12y minus 5y, positive 56 minus 14 is equal to 0 minus 0. And then the same, we use any one of them since x plus 3y plus 14 is equal to 0. So the point is 4, negative 6. A little bit more is I want you able to sketch the graph by changing the line to slope-intercept form. X plus 3y plus 14 is equal to 0. So 3y is negative 1x and then minus 14. So y is negative 1 over 3x minus 14 over 3. Therefore, if we sketch the graph, I know that the y-intercept is negative 14 over 3. The slope is negative 1 over 3 going downward. Do the same for the second line. 4x plus 5y plus 14 equal to 0. So therefore, this is negative 14 over 5 is approximate here. And then going downward, and this slope is lower than this one. This is negative 3 point something. However, this one is negative 8. So that means it's go down quicker. And the point that we just found, it is the intercept point here, the point of intersection. So we find that the point is 4, negative 6. Which is quite consistent with our sketch. Of course, this is not on scale, so it's not that accurate, but it gives you the approximate position of the intercept point.